Hi, welcome to Ushendra's engineering tutorials. Properly making use of delta to star and star to delta transformations will really help to simplify the circuit analysis. So, the basic of that transformation here, it would be convenient for a beginner if he starts from delta to star, because we have to make use of some equations throughout the evaluation. So, stay with me here. This is how delta connection looks like. It's a delta symbol over here. It's a delta here. It's like this, giving some names to the nodes. So node 1 and node 2 and node 3, right? And resistors over here, giving the names RA, let it be RB, the resistor, and let it be RC. Now this network, the delta network, is to be converted to a star network. How that star network looks like here? The star network looks like this. It's like a star connection, this, and giving the same names, the same 1, 2 and 3, 1, 2 and 3 over here. We need to have a resistor R1 in terms of RA, RB, RC. We need to place a resistor R2 again in terms of RA, RB and RC. Another resistor over here, given the name R3, same in terms of RA, RB and RC. So where to start from? Guys, a small simplification over here. Looking from a small modification over here, what will be the equivalent resistance of this network between 1 and 2? Let this be the node 1 and let this be the node 2. What is the equivalent resistance viewing from this point, this side? What is the equivalent between 1 and 2? It's like this one. And in that case, we can see RA over here, RA over here, RA over here, and RB, RC. The series combination of this one is in shunt with RA. It's like the modification will take like this one. It's this one, the same connection. RC, we have RC, and we have RB over here. We have it's a RB over here. Okay. So the series combination of RB and RC is in shunt with RA. So what will be the equivalent resistance here? It's a RA is in shunt with the RB plus RC. This is the equivalent resistance when looking from 1 and 2, this one. So how to write this equation? It's a RA into RB plus RC upon RA plus RB plus RC of this network. And what is that resistance looking from 1 and 2 of this one? It's now we have only from 1 and node 2. We can see this becomes invalid when viewing from 1 and 2. The equivalent resistance of this network will be like this. It's simply the series connection of R1 and R2 exist between 1 and 2 of this network. So what is that equivalent? Now this will be equal to, if this is equal to this, this equivalent resistance should be equal to R1 plus R2. A very important one, please. Let this be equation 1. We need to make use of that equations once again. And on the other hand, with the same discussions, what would be the equivalent resistance while looking from the point 2 and 3 here? From here, it would be a change in the color over here. Please make a note. It would be like the same thing over here. Between 2 and 3, viewing from this point of view, it gives us 2 and 3. It's like this. Let it be 2 and let it be 3. We have a resistance RB over here, and this RA and RC are in series and in shunt with RB. It's like the equivalent resistance would be like this one. We have this RC and RA in series with this one, RA in series with this one, and this would be the equivalent resistance while we view from this point. So what is the equivalent resistance of this one? RB. Now here, putting that in an equation, RB is in parallel with RC plus RA. So how to write this equation? It's RB into RA plus RC upon RA plus RB plus RC of this network. What about this one? While viewing from 2 and 3, it's if this is 2 and if this is the node 3, what we have over here, this becomes invalid when viewed from here. It's R3 in series with the R2. This becomes invalid when we view from this point. So what is that? Equivalent resistance. This will be, if this is equal to this, the equation will be R2 plus R3. Guys, that's let that be the equation 2. This is equation 1 and this is equation 2. We need to look back to this one while evaluating. This will be given, the delta values will be given, that has to be transformed into the star, and we need to evaluate the values of R1, R2, R3 in terms of this one. Then we'll have to make use of these equations. We have to look back to this one. And what about the equivalent resistance between when it's viewed from this point and from this point, right? With a change in the color, please make a note. Between 1 and 3 of this network, between let it be 3 and let it be 1. So what exists over here? It's RC. It's RC between 1 and 3, and here this would be the series combination of RA, RB is in shunt with this one. This is how it looks like. We have a resistor and another resistor like this, given the names. What is that? It's a RC over here, so RA and RB. This will be RA and RB. Please make a note. And what will be the equivalent resistance in this case? RC is in parallel with the series combination of RA plus RB. So the complete expression, the exact expression for this is RC into, what's that? RA plus RB upon the total resistance RA plus RB plus RC, and the equivalent resistance of this one. So viewing from this point, it's 1 and 2. This becomes invalid in this case. Between 2 and is that 2? No, it's 3. I'm very sorry. This is 3 and this is node 1, and we have R3 and R1. We have R3 and R1 in series, right? So from this point, this becomes invalid. We have R3 and R1 into the picture. The equivalent resistance would be this, and in putting in the equation, it's this. If this network is equal to this network, we'll have this equation will be equal to R1 plus R3. And now this is another important equation. Please let it be equation number. This is 1, this is 2, and this is 3. Making use of these 3 equations, we can evaluate the final expression for R1 and R2 and R3. Please make a note. Now these are the important 3 equations which we will make use of in evaluating the resistances for R1 and R2. So what would be the resultant if this is done here? If equation 1 minus equation 3, let's see if what would be the resultant, right? So what is equation 1? Simply writing it directly, it's RA plus RB plus RC in the denominator of the first equation. It's in the numerator we have RA, RB, please watch carefully over there, plus RA, RC minus the third equation. Again we have RA plus RB plus RC. In the numerator we have RA, RC plus RB, RC, which is equal to what? This minus this, R1 plus R2 minus of R1 plus R3. So solving for this one, what we have in the simplifying this one, we have RA plus RB plus RC as usual in the denominator because it's common. So in the numerator we have RA, RB plus RA, RC minus of RA RC minus RB RC, right, which is equal to what? R1 plus R2 minus R1 minus R3. Okay, so here it's a partition over here, don't mind. And here, as we go ahead, what gets cancelled over here in this expression of the numerator? It's a RA plus RA RC minus RA RC gets cancelled, yeah. And on this side we have plus R1 minus R1 gets cancelled on that side. So simplifying, even more simplifying for that one, what we have is it's RA plus RB plus RC in the denominator as it is, RA RB minus RB RC over this side, and it's R2 minus R3, R2 minus R3. Let it be equation 4. Equivalent equation for 4. So let's check if what yields if this is done, this equation 2 plus equation 4. So what if these two are added? What is the equation 2 over here? It's in the denominators commonly it's RA, so without any mistake, RB plus RC. We have this one of the second equation, and straight away it's RA RB, it's RA RB plus RB RC plus RB RC, and this is the equation 4. The simplifying this one, we have the same denominator, and this comes into the picture. It's a plus of straight away. Okay, please make a note, it's not that tough. RA RB, it's addition, right? So as it is, this comes down as it is, minus RB RC, which is equal to what? To the right side of this one we have R2 plus R3, we have R2 plus R3, and over here we have plus R2 plus R3. So guys, careful watch, we'll make sure that something gets cancelled over here. Plus RB RC minus RB RC gets cancelled in the LHS. On that side we have, hey guys, I'm very sorry, it's it should be R2 minus R3, right? This isn't plus R3. I'm very sorry, I'm taking back my word. It's R2 plus R3 from here, R2 plus R3, and it's R2 minus R3 from here, R2 minus R3. Yes, in that case plus R3 and minus R3 gets cancelled. And yeah guys, continuing with the red ink, okay, it's black over here, so that you don't get confused over here. So what we have is RA RB plus RA RB, that gives twice of RA RB by, yeah, continuing on this side. Okay, so it's twice of RA RB in the numerator upon RA plus RB plus RC, which is equal to what? R3 got cancelled, we are left with R2 plus R2, which gives us twice of R2, twice of R2, and this gives the expression for R2 in terms of RA, RB and RC. So what is the final expression here? 2 gets cancelled, here 2 gets cancelled, and R2 will be equal to RA RB by, what's that, total resistance, RA plus RB plus RC. Now this is the expression for R2. In the same manner we can evaluate the expression for R1 and R3, and then can be transformed. So this was the resultant when the two equations 2 and 4 were added. We obtained R2. We evaluated R2 making use of 2 and 4, 2 plus 4. So what would be the resultant if it's a what would be the yielding if 2 minus 4, equation 2 minus equation 4? Writing it directly, okay, because both the denominators are same, so writing the fraction directly, R2 is that. So what is that? In the denominator we have RA plus RB plus RC for both the ratios, and R2, what's that? R2, it's a R2 RA RB plus RB RC, and this negative that comes over here, this negative will be applicable for here. It's a minus of this one, RA RB, it's already negative, into negative, that will be positive, so plus RB RC, RB RC. On the LHS it's RC, don't get confused, it's RC. Okay, it's a RC. LHS, this minus this, it's a R2 plus R3, and this negative minus R2 plus R3. So a careful watch, something gets cancelled, RARB plus RARB minus RARB gets cancelled, and here plus R2 minus R2 gets cancelled. So we'll be left with here, it will be R3 plus R3, twice of R3 on this side, and it's RA RB RA plus RB plus RC in the denominator as it is. What we have in the numerator, it's twice of RB RC. Yeah, it's twice of RB into RC. So this two on either side gets cancelled, and the resultant for R3, it's here, the equivalent resistance for R3 in the delta to star transformation, R3 is equal to what? RB RC upon RA plus RB plus RC. This is the resultant equivalent resistance to be plugged in while transforming delta to star transformation for the value for R3. Make a note please. What would be the resultant for equation 1 minus equation 2? What's that equation? It's guys, writing the ratio straight away without any simplification, like simplifying the final R1 RA plus RB plus RC as common for both the ratios, and 1 minus 2, right? In the sense this minus this, it's a RA RB plus RA RC for this one 1, and for 2 it's a negative, so minus of all that, minus RA RB again minus of RB RC in the LHS equal to this minus this, right? So we have R1 plus R2 minus R2 minus R3, and very clearly plus R2 and minus R2 gets cancelled over here. It's what get cancelled? RARB plus RARB minus RARB gets cancelled here, plus RARB minus RARB gets cancelled, and what would be the resultant? It's here, the resultant is what we have, RARB RA plus RB plus RC in the denominator as it is. We have RA RC minus RB RC in the numerator, which is equal to, guys, it's a R1 minus R3. Let this be equation number, it was 4, right? So let this be equation number 5. So what would be the resultant if what would be the resultant if this 5 equation 5 minus plus 3? Let's check. We have to evaluate for R1. So what would be equation 5 plus equation 3? What is equation 5? It's straight away writing that straight away. RARB RA plus RB plus RC as common for both the ratios, the fifth equation and the third equation, right? And it should be added in the sense this comes up RA RC minus RB RC of the fifth equation plus of the third equation of this one. So it's a plus, what's that? RARC RARC plus RB RC. This is for the LHS, and RHS we have R1 minus R3 plus R1 plus R3, and what gets cancelled over here? It's a RBRC, guys, I guess. RBRC, yes, minus RBRC plus RBRC gets cancelled. Here it's a minus R3 plus R3 gets cancelled, and the resultant would be here, it's a RARC plus RARC, twice of RA RC by RA plus RB plus RC, which is equal to R1 plus R1, it's twice of R1, and what gets cancelled here? It's 2 on either side gets cancelled, and this would be my final equation for R1 also. R1, R2 and R3. Yes, these, making use of these equations, we can, while transforming a delta to star connection here, in the sense it's a RA-RB, A, B, C, 1, 2, 3, resistance 1 should be this value, and resistance 2 should be this value in terms of, and resistance 3 would be this one. So this is the transformation. It's only from delta to star. Making use of these equations, we can come back, even that is true. Let's do it. Let's go ahead. Now it's time for star to delta connection. Making use of the same way expressions. What would be the resultant if R1 what would be the resultant for R1 into R2? R1 into R2 will be equal to, multiplying these two, will be having here, multiplying these two, it's a RA plus RB plus RC whole square in the denominator, and this into this, that yields us here, it's from R1 we have RA into RA into RC from R1, and from R2 we have RA, so that will be RA square into RB. This would be the resultant for R1 into R2. And what would be R2 into R3? R2 into R3, better if we change the color. R2 into R3 the same, RA plus RB plus RC whole square in the denominator, and from R2 we have RA into RB, and from R3 we have RB into RC, so that will be yielding RB square into RC, right? So expression for R2 into R3. Now what would be the resultant if we go for R1 into R3? R1 into R3 will be equal to the same, the denominator will be the same, RA plus RB plus RC whole square from both R1 and R3. So in the numerator we will be having RA RB into RC square, right? And we have to evaluate, this will be given, we have to evaluate RA in terms of R1, R2, R3, RB in terms of all these, RC in terms of this. Making use of these same very expressions will be, now what would be the resultant if we add all these? The resultant, what would be if we have here R1, R2 plus, what is that, R2, R3 plus this one, R1, R3, which is equal to, commonly the denominator will be RA plus RB plus RC whole square in the denominator for all the three terms, and we'll be having here, it gives RA R1, R2, RA square RB RC, it's adding, right? So this one plus the second term R2 plus R3, that gives us RA RB square RC plus this one, we have RA RB and RC square. So this is the resultant for R1, this one, when all the three equations are added. Now what we have on the other hand, what if we take out here, it's a denominator, no simplification in the, no change in the denominator, it's a RA plus RB plus RC whole square in the denominator. Taking out RA, RB, RC as common from all the terms. Here taking out RA, RB and RC as taking out common as from all the terms. So RA, RB, RC has come out. So we'll be left with RA over here, RA, and RA, RB, RC has come out. So we'll be left with plus RB plus RA, RB, RC has come out, so we'll be left with RC. And in this case, something gets cancelled in the numerator and in the denominator. It's this one, the square, like this, and this term gets cancelled, right? So we are left with, guys, this one. This can be RA into RB RC upon RA plus RB plus RC, which is equal to what? Which is equal to R1 plus R1 R2 plus R2 R3 plus R1 R3, this side on the LHS. Now what is this? Look back to those three equations carefully, and this could be substituted with something else from that side. From these three equations, this could be. So going ahead only for RHS, RA as it is. What is this entire term? RBRC, this one. So that's R3, this one. RBRC, this one. So it's a R3, which gives us an expression for RA. So from this one, pushing this R3, which is in the RHS to LHS, what we have is RA. What's that? RA will be equal to R1 R2 by R3 plus, gets cancelled and gets cancelled, so we have R2 plus R2 from here and R1 from here, because R3 gets cancelled over there. R1, guys, our expression for, it's A, don't get confused, it's A, suffix A. So our expression for RA here, while transforming the star connection to delta connection, yeah, this is the 1 and 2, we need to have RA, so that gives us, this is the expression to make use of while getting the value of RA. This was the resultant when all the three expressions were added, final expression. This was reduced to R1 into R2 plus R2 into R3 plus R1 into R2. We had this previously, I have rewritten this for convenience. And this could be a small change over here, a small arrangement over here. This could be written as RB into RA-RC by what? RA plus RB plus RC. Now watch carefully, what can be this one? RA-RC. This could be substituted with something from that equations, in the three equations. What is that? RA-RC. So this would be our expression R1 R2 plus R2 R3 plus R1 R3 will be equal to what? RB as it is. We are evaluating for RB, and RA-RC by this one, I guess we can plug in with R1 from that expression, R1. And finally our expression for RB will be, that comes this side, this one, this R1, we want the value expression for RB, right? So that will be RB will be carrying this R1 to this side, this gets cancelled, so we'll be left with R2 plus we have R2 R3 by R1 in this case, and even this R1 gets cancelled, and so it's a R3, our expression for RB. Okay guys, is that clear? This one for RA, this one for RB. So how to evaluate for RC? The same thing. This expression here, this rewriting this expression for RC, we have R1 R2 plus R2 R3 plus R1 R3, which is equal to, this can be rewritten as, it's R3, don't get confused, it's R3. That could be written as RC into what? RA RB by RA plus RB plus RC. So now this entire expression, this one, what? This RA RB could be plugged in with something else from those three equations. It's a RC as it is here. It's a RC as it is from here. RA-RB, I guess that could be plugged in with RA-RB. Where is that RA-RB? It should be R2. So here we have R2 over here, and we are in search of RC. That would yield us RC R2 carrying to this side, this one, and this one gets cancelled, so it will be R1 from the first term. This R2 gets cancelled from here, and R3 plus R3. Why? Because when this is shifted, that R2 and this R2 gets cancelled, and we'll be left with R1 R3 by R2. Guys, these are the expressions for RA. Where's my expression for RA? Here we have RA. When this is given, to transform this, RA will be this, and RB will be this, and our RC will be this, star to delta. Believe me, a lot of applications to be done, a lot of circuits will be simplified making use of the star, if we make use of the star and delta star transformations properly. Hope you understood the derivation completely. Nothing is hidden, everything is transparent. Make use of the derivation. Please support me with your valuable share and a subscription. Thank you so much.